Hi, everyone. Thanks for the first talk. It was very nice. And this is a little bit opposite to the first talk because I don't want to speak about what's inside the Jupyter, but what's behind the Jupyter. Who haven't heard about the Jupyter? Sorry for the, I will tell sometimes Jupyter, don't care about it. So who haven't heard about Jupyter earlier than previous talk? Cool. So everyone use it. So if someone forgot the questions on Slido, who we are. I'm the part of business intelligence team in Almakery, Czechia, as known as LMC. It's about 20 people using Jupyter. We call them analysts. And then two other people, data ops or data engineers, we call it tech. We started with Jupyter Hub and Lab in 2017, and we like open source and latest technologies. Maybe the question, who knows Jupyter Hub? Okay, it's not too much, but yeah, I will talk about Jupyter Hub and Jupyter Lab. We started on the on-premise infrastructure, and it was like this because we had really deep knowledge about what happens behind the Jupyter Lab and Jupyter Hub. Basically, Jupyter Hub is just a part of, it's just a server who spawns the processes. Like it can be Docker, it can be like Docker spawner, it can be virtual machine, it can be process, or whatever you need. So it's basically like Jupyter Hub. You log into the Jupyter Hub, and there is a kind of login process. You can set a lot of login like providers. We used LDAP, and if you log into the Jupyter Hub spawns the process, or in our case, the Docker, with separate environment or isolate environment for you. So basically, it was like every user in the Jupyter had their own playground. So there was no interferences between the containers of the users. So if the user installed some libraries, these libraries was just for these users. So we had a base images where the basic libraries was installed, and then the users could install another libraries, and these libraries was there in the container, so they could use it. And of course, the other users can install another ones, and etc., etc. So what was the advantages and disadvantages of this? We had a deep technology knowledge because we knew what's on the behind. There was a HashiCorp Nomad, what's the containerized environment or Docker environment with the Docker hosts, and you just spawn the Docker containers to these Docker hosts. And that was really good because we exactly knew what's behind the Jupyter or Jupyter Lab or Jupyter Hub, doesn't matter. We had a private and shared persistent storage. What was really, let's say, we had the shared one, but we haven't had the private one. And that was the trouble. But shared one was okay for us at this time, because we were okay that if some user wants to connect, for example, to the Snowflake database, we usually use the keys to log into the Snowflake. And you have to store somewhere the key, and where to store it if you have a just shared persistent storage. Okay, it was shared. So that was one thing what we need to improve in the next versions. There was no secret management because usually we just connect to Snowflake or BigQuery or a databases or data warehouse like this. But there was no secret management, but it was not so big pain for us. It was the per user same isolated environment, or at the beginning, it was the same isolated environment. Of course, users could install other libraries, and they can prepare the environment for specific for the user. it was centrally managed, what was really important for us, because we don't want to bother users with installing Jupyter, running it somehow, running it on their local computers. So we provide for them the resources, like the Docker host or Docker hosts. It was like Docker host, it has maybe like hundreds of gigarams and hundreds of CPU. So basically it was like, okay, use whatever you need. And if you need more, just let us know, or we will see it in the monitoring. So centrally managed was really important for us, and somehow we need to log in the users and recognize what's the username, of course, because you need to set the privileges for them, etc., etc. So there was an LDAP authentication. So that's basically what we need from the Jupyter. And okay, then companies moving to AWS. Yippee! Why not? So we said, okay, let's use Amazon SageMaker. To be precise, use Amazon SageMaker Studio. What's the replacement for Jupyter managed by AWS? Okay, very good idea at the beginning. But after 3 weeks, I looked like this, because it's very nice. I would like to say the advantages of this at the beginning. If you use the machine learning stack and all the things from the SageMaker, because SageMaker is not just the SageMaker Studio, there is a like machine learning and model training, etc., in AWS. Use it. But we don't use the machine learning stack from AWS. We really needed just Jupyter. And of course, some libraries behind it. And if you don't have to take about it and infrastructure and updates, etc., use it. But otherwise, there is a lot of things what you have to solve, and it's not easy to handle this. Because if I start deep knowledge, okay, someone doesn't need to have a deep knowledge of this solution, but as it is managed and modified by AWS, you can't get the deep knowledge. What's not a trouble until you have a trouble. Because if you go into the issue, you are not able to solve it. Or you are able to solve it, of course, with the support of AWS, and it really depends how much do you pay to AWS. Shared and private storage, it's almost impossible. You share everything or you share nothing. But separate it to two parts, where you have a private part for the user, and then if you have where you have a shared part for the user, it's almost impossible, because at the back of the SageMaker Studio, there is a EFS mount, and EFS, it's called Elastic File Storage, or Elastic File Storage, and you can mount just one Elastic File Storage under the running instance, so you are not able to separate it to private and shared part. So yeah, that was, for us, it was really impossible to use it in the multi-user environment, because if you use it as a single user, it's not a trouble. But if you want to share the storage, and why to share the storage? Because if someone writes an analysis in the Jupyter, often they want to share it between the users. Or if another user come to the Jupyter and say, hey, I need to say this analysis, how you want to share it? It's easier to store it somewhere in persistent storage, and just to access this file, open it and use it in your kernel in Jupyter. Very simple, but it's not possible to do it, or it's very hard to do it in SageMaker Studio. Secret management, that's coincidence with the previous point, because if you have everything shared, it's not easy to separate the keys and isolate them somehow in the private part of the storage. per user isolated environment, it's not the trouble. But if you use it as a like non-multi-user environment, because if you use multi-user environment, what's called studio spaces, and you start with the studio spaces, there is a trouble that if you have same resources for the kernel, they share these resources. So one kernel can be used by 2 users or more users. What's really trouble if you run like CPU or RAM consuming jobs, and you share one kernel, you can kill the other jobs from the other user. And there is a way how to solve it, but you have to rename the kernels and put the different names in the same kernels with the same resources, but you just have to rename there with the separate names or unique names. Centrally managed, it's easy to use it for end users, but not for administrators. And there is a really complicated like startup scripts, they call it lifecycle configurations, and it's okay until you have an issue in it. If you need to debug the lifecycle configurations, it's like, hey, is it really ready for production use? Definitely it is, but not in our case. LDAP authentication, yeah, you can use Amazon SSO, or if you don't have or don't use the Amazon SSO, you have to use the login to Amazon console. So someone has to give you the access to Amazon console. And unfortunately, we don't have Amazon SSO at the moment because we use Azure AD authorization or Azure Entra ID, how it is called at the moment. And we couldn't use the Amazon SSO. So we had to provide the credentials for the console, Amazon console, to the users. So the question was, hey, after 3 weeks, did we expect too much from SageMaker Studio? I would say not. And yeah, we say after 3 weeks, hey, that's not the way. We have to solve a lot of things. And somehow it does not make sense to invest more time into it. So we find a coder. If someone needs to find it, it's coder.com, and hope we stay with the coder for a while. We use it for like 8 months at the moment. And what is it? Coder is basically a self-hosted developer platform. You just install it, it provides you the login window, it provides you the backend, how to deploy the servers, and how it works at the background. Basically, it just spins the virtual machine or Docker containers on various platforms like AWS, Azure, Google Cloud Platform, Kubernetes, or Docker in Docker, and it spins up via Terraform templates. So who knows Terraform templates? You can use Terraform across the platforms. And what's really nice, it gives you the access to the services running inside the VMs or Docker, and a lot more we will see. After 3 days, I was like this, hey, after 3 weeks with the SageMaker Studio, it was very nice to get to this technology because it's really simple. All the things what we have to solve in SageMaker Studio was nearly solved by default in this one. So deep knowledge runs on EC2 machines or ECS, Elastic Container Service in AWS. We have it in AWS. If someone needs it in Google Cloud Platform or different platforms, of course, there will be some specific issues, but basically it should be same. Shared and private storage, where we need to separate the credentials for the users, or like, let's say, how to call it, private files or private folders, what you don't want to share with the others. It's not a trouble because we can mount to EC2, we can mount to EFS shares or EFS storages, and then we can just mount the user specific EFS storage to EC2 machines. So they have completely separated private for every user and shared one. So in shared one, they usually work on daily basis and they share the work with others. So if they need help, they just open together the Jupyter notebook and they can work together. Of course, you know, if you edit Jupyter notebook onto places, how it ends, but you can do it, or at least you can just open it and run it in your kernel or just copy it. Secret management, we don't really need it because we just have keys for the databases, and it's stored in private storage. Per user environment, in isolated environment, separate EC2 instances, so there is no trouble with sharing resources, or the environments are completely separate. So if you, and what's really nice, that in Coder, you can choose the option, hey, I need the instance with 16 CPU and 1 terabyte of RAM. And you can just choose it at the beginning and start the workspace with, they call it workspace, and start the workspace with it and just use it. And in Terraform template, you define something called startup scripts, or startup script is basically bash script. But if someone or who knows the basics of the Linux is able to write it, so you just write a start script and inject it into the Terraform template. I can show you, and you just start the machine. And again, at the beginning, it's the same machine for all, and it has an EBS volume under this machine. So if you stop it, the data are persisted in this EBS volume, and if you start it again, you are in the same state. So you don't have to install the libraries and stuff like this until you delete the EC2 machine. So authentication is via OIDC or SAML or SSO. So it's not a trouble. We could connect it to the Azure portal or Azure AD and use the users what we have in Active Directory. What's really nice, you have like auto suspending of instances, because if you can imagine that someone starts the machine like tens of CPUs or hundreds of CPUs and hundreds of gigarams, it can be pretty expensive. So there is no money wasting. You can set up that, hey, I want to run the instances for 6 hours and then stop it if there is no running processes from the Jupyter. And what's really nice, you can have auto start there and auto stop as well. So if you need, because the task is, hey, stop it at 8 p.m. and start it on 8 a.m. morning when the people goes to the office, and you can do it easily just through the UI of the coder. Sharing of application prototypes and developers onboarding. So of course, if there is a new developer, you have to somehow onboard him, start the IDE, install all the things. There is nothing like this. Everything is prepared on just one click and in one Terraform, and you can define more templates and start different workspaces for the different teams, for the different use cases, or whatever you need. So there are no disadvantages, or we haven't found them after 7 months or 8 months. And yeah, what you need is basically knowledge of Terraform and Linux. And of course, the platform where you deploy it, or if it's EC2 or AWS, or depends on the platform. So yeah, let's go for the live demo. Hope everything works fine. If not, we can use the workspace. Yeah, this is the old one. We have a PyData Prague. So I am logged in into the coder. So you have just workspaces. I have just one workspace here. If you see it, it's Jupyter or template. Is the Jupyter, you can define the different templates. If it's a template example for Julia or whatever you need in it, you can prepare the Julia template, or just template for different teams working with PHP. Or if you need to run the Docker, who knows the dev containers from VS Code, you can prepare the environment for the Docker and start the dev container from the coder environment. But you will see it. If you open the workspace, we have some issues here, but it doesn't matter. We can restart it. Never mind. Just restart it. And this is what it basically does at the beginning. Doesn't matter. Let's leave it restart. And what's really nice, if you think about it, how it works, it spins the virtual machine and installs some processes on the virtual machine. And one of the processes is Jupyter or Jupyter Lab. You can open the Jupyter Lab from the window here. I will jump back to the presentation. Yeah, you have like icons, or they call it applications, like here in the coder. So you can open it in the Jupyter Lab. Let's basically open the browser window, or Visual Studio Code Desktop, or Visual Studio Code Web. So it really depends what like developer experience want you have, because if you are in Jupyter Lab, or if someone tries to start like IntelliSense or code completion, sometimes it's very hard to achieve really nice responses in the Jupyter for IntelliSense or code completion. But if you open the code in the VS Code desktop, you have like desktop experience, like VS Code desktop experience, but kernels runs on the server. So you are connected. It's basically SSH connection to the server, and you run all the processes on the server. So you have the resources from the server, and you can just use it in your local development IDE. So that was really nice for us. And for example, if you start in the terminal or in the Jupyter, if you start who knows Streamlit, doesn't matter. Fine. If you start this, it's like application who serves some like interactive dashboards or interactive application with data. It basically starts the web server, and you can access this web server from your computer or within your network. Because if you open the port to the virtual machine, everyone can access it. So could you imagine if someone needs to prototype the application, he or she just write it in the coder or in the coder instance in Jupyter Lab, or just save the file in this environment, start it, and you can share the link with everyone in your company or in your network, and he can or she can use it. For prototyping, it was amazing for us, because we have a lot of applications like, I need to check it, please could you access it? Where? You have to deploy it somewhere. You have to deploy in the dev environment or somewhere else. Like this, you can deploy it like in 30 seconds and share it with the others. Yeah. Doesn't matter. Let's check it. Terminal is running. It looks like there is no internet connection, but that's basically what it is, usually with live demos. Because usually it's pretty fast. And let's leave it like this. We will see if it runs or not. Let's try the restart again. But that's basically what is Coder about. It spins the virtual machine for you, and you can access the virtual machine very easy. Make a development on the virtual machine or remote environment, or in Jupyter Lab, or Visual Studio Code Desktop, or Visual Studio Code Web. Or if you add your own application and you start your own application, for example, Headlight. Headlight is our application if someone needs to present the Jupyter notebook, usually I notebook files. We just render it to HTML and we can use it we write a small application based on 11D, like simple static, it's simple like static page generator, and we can present it to the others. So we have like it's called like ad hoc analysis repository, or you can just open it and you see all the analysis, and you don't need to go to the Jupyter notebook, and you just have a output of the Jupyter notebook. Basically, I can try to open it, but yeah, there is a trouble with the not with the SageMaker, with the Coder. Doesn't matter, but we can show it like this, and you can. This is on the left side. There is a Jupyter notebook, and on the right side you see the output of the Jupyter notebook, and this is you basically open the web page where you have the list of the exported notebooks, and you can access it. There are some text and menus and stuff like this. Hope this is gonna work in a moment, and I can show you. Otherwise, we can take a beer or water and whatever, and I will try to fix it. And I can show you, because this is very nice. And there was something like it's called. It was from Airbnb, but they stopped developing it, and I don't understand why, because I think a lot of people needs to present the IPython notebooks somehow, and they don't want to share and run the other users to be able to run it. They just want to share the output, and we haven't found a like proper solution for us to have this options or opportunity. So yeah, unfortunately, live demo is not working as usual in live presentation. Let's try it once more. No, it's not working. I have no idea why. There is probably no internet connection. There is internet connection. Yeah, maybe. Let's try once more. Because yeah, there is an issue. I don't know if we are able to solve it at the moment. We can restart it once again. Yeah. Back to the presentation. So, sorry for the live demo, but if you like it, or if you have any question, I'm here. We can talk, and I hope I can fix it in a short time. Or it's not about fixing; it was working like 10 minutes ago, as usual. And if you like it, we want to hear from you, because we need one pair of hands to the tech team. So technologies are here in the background. So if you like it, don't hesitate to contact me or chat with me, or contact us on the emails like this, and we can discuss the possibilities. And of course, if you have a question, please ask, and thanks.